One of you flip the light switch down for us, please. And we're going to take a look at page 39. Now, I know I gave you the worked out version that I asked that you just take the opportunity to take a look at yours, and if there was any questions, we would take care of them today. So let me just move this forward. All right, so on page 39, what kind of questions did you come across that even by looking at my work, or maybe my work was wrong? What did you get? Remember, we're talking about and. We're also talking about or. And graphs, when they're done, they come together. And or graphs go away from each other. Okay. So there are times that they might have something listed as an and. It's going opposite directions. Thank you. Oh, and I found a name. Perfect. Thanks, Jacob. So what questions come up on that worksheet? I know all of you should have it right because you had my work. But was there anything? Yeah.
13.
Yeah, buddy. Number 13. Let's take a look. 13. So we have x is greater than 5 or x is less than 3. All right. So I'm going to put this on a number line first. It's already solved for us. So we have, say, 3 here, and I have an open dot going this way. And I have 5 here, and I have an open dot going that way. Definitely falls into the category of being an OR graph, okay? But then we want you to do the interval notation on this. So you know this goes to negative infinity, and this goes to positive infinity. So we're going to read it from left to right. So reading it from left to right, negative infinity to 3. And then you're going to put the word or in there. And then this was at what, 5? No, it's 5. And this goes from 5 to infinity. Done.
How come most of those problems are no solution?
Which can
They don't overlap.
So if we had this listed as and, if I would have had this word be an and, this would be no solution. Okay? Because an and has to come together. So the difference between the or graph and the and graph is this. Let me pick 0 would be right here. Agree? Roughly? If I take 0 and plug it in, I get 0 is greater than 5. That's false, right? Or 0 is less than 3. That's true. So remember the analogy I used? My friend Matt and I went to the store. That meant we both went to the store. If I said my friend Matt or I went to the store, one of us or even both of us went to the store. Okay, so you're looking where it makes it true. So the or situation allows you to have one of your sides untrue if you pick a point. Now, if I pick, say, 4, because 4 is between 3 and 5, right? If I pick 4, 4 is greater than 5. That's false. 4 is less than 3. That's false. So in between here, we have false region. Things don't work. Yeah. 6. All right, number 6. So this is an or problem. So it should be shading away from each other, and it's already worked out. So I'm going to draw a number line. I don't know. Let's see. Negative 2 is here. 0 is about here. 6 is about here. All right. I want values that are less than 6. So this is going to shade this way. And then I want values that are less than or equal to negative 2. So that's also shading this way. So it's or. We only need one. We need to find where one thing would be true. So let's pick a number outside here. 10. Okay? If I plug 10 in, 10 is less than 6. That's false. 10 is less than or equal to negative 2. That's also false. So nothing over here is going to work. But if I pick, let's say, that's a 6, right? Let's say I pick 5. Okay? Which is somewhere in there. 5 is less than 6. True, right? 5 is less than negative 2. Well, that's false. But because it's or, I only need part of it to be true. So everything from here to negative infinity will be your true answer. Okay, because you only need one part. Both parts can be, but they don't have to be. So if you're reading this inequality, It's -8 to 6 rounded bracket. That's all you have to do. So this kind of overlaps this problem. What do I get when I start getting down here? It's true on both. So let's say I take -10. -10 is less than 6, true. -10 is less than -2, true. You get true on both. So, or you need to have either be true, or true, false. One or the other. Or it could be both. That's why it overlaps. Okay? Another way I've seen this problem done is, maybe this will clear it up. Let's bust out the highlighter, see if we can make some. So if I do this problem, this is this. Is that okay? And then if I change this, and this is this.
That is true.
Okay? So do you see the green? Because I blended the blue and the yellow, so we're in art class. The green is where everything is totally true. We get two true statements on both equations. Okay? The blue is where we have one of the equations being true, but the other one is false. And we're looking for where the solution is, where they're both true, or one or the other is true, but not both. As far as this being an AND problem, if I had this listed as an AND problem, this is where the AND problem would be true right here. But because the word OR allows one event or the other to take place. Is that okay? What other questions did you come across on that? It's different thinking, I'm telling you. What are you going to use it for? Math from here on out. So I can't tell you where the real life application of it is really out there, but really smart people in math said we needed to teach it, so we teach it. Question anymore? Going once? Going twice? Going 3 times? Okay, make sure your name's on it, please, and turn that in as well. Anything else? And if you're turning in anything else, then please pass that forward. Thank you. Thank you. And thank you. Oh, wait. Thank you. Thank you. And thank you. All right, any more out there I need to know about? Did you get it? Oh, you're awesome. I don't need to put a mark on it all. I know it all.
Oh, I thought someone was right behind us. Like, my light is fast.
All right. All right, compound inequalities. This is kind of continuing on a little bit. I'm going to take this off this little Jim Dandy. All right. So compound inequalities we're working on. This is 2 or more problems on one number line. Does that make sense? So it just means we're trying to put multiple things on one graph. Seem okay so far? All right. May I move on? Thank you. All right, so first thinking, group thinking. All right, let's see what this says. Some of you have done a science lab where you turn pennies gold. I don't know if you have or haven't. I don't know. I think it's called electrolysis, I believe is the thing. You put a gold ion in your solution and you conduct an electrical current across your penny, and the ions of gold adhere to it, so it appears that it's gold. So in order for the penny to turn gold after plating it with zinc, the temperature must reach at least 270 degrees Celsius. If the temperature goes above 295, however, zinc will burn and the penny will turn black. How can you tell the science class is working with the right temperatures? And how will you convey this information? So, what is our goal during this lab of science? Do we want to make the penny black? Well, some of you are like, heck yeah, let's do it. But some of you are like, no, I want the shiny gold coin, right? So what do you think?
Gold.
Trying to make the.
So can we all agree that we're trying to get to this gold color? Is it really gold? No, we're using zinc, and when it oxidizes at that temperature, it gets us to be gold. Yeah, it's against the law actually to do this because you're
Like that one girl at the presentation thing, she started ripping up the dollar. That's
There.
against the law. Yeah.
Wait, it actually is.
No, it
It's
isn't.
about
Yeah, it is.
it's facing public currency.
To rip a dollar?
Uh-oh, someone's here. Oh, thank you. Who do we got?
It's me.
Uh-oh, cool.
Yeah, you can. Well,
It is you.
it's like,
Oh, you got that.
no, I have no idea what I did this time though.
No, it's just the West Clinic, so that's the nurse.
I haven't been over to the things that I just
All right. So what temperature does this gold have to be? So at least means this, and it can't go above this. So what's my minimum temperature here? And what's my top temperature? So if your solution is somewhere between there, your penny's gold. What happens if your solution's over this way? I don't think it's gold. And what happens when it goes above 295? Well, they already said that if it goes above that, it's going to burn and it will turn black. Okay, is it still the same chemical reaction? Well, you're talking about ions. What's an ion? I don't know. You have positive ions and negative ions. Positive ions, which attract things, negative, give off. I don't know. I taught chemistry before.
Oh, yeah. That's nice.
I'm certified in all math and all science. So
That's kind of
if you ever need help in science, let me know. I can do that too. But
Don't
don't
fly.
do what?
Yeah, this spot.
Yes. Yes.
I had her in 8th grade.
I have her right now. I have her.
Who is this? I don't know who this person is.
She came from campus, middle school.
What is her name?
Miss
She's a demon.
Amy Flatten.
Flatten? Like flat ton? Like that?
Yes,
Yeah.
Flatten.
Flatten?
She has different hair. Yeah. She does?
You know Mr.
See the show? Which
I'm sorry, what?
She's so mean.
Yeah, I know Supla.
Yeah, she's like right next to me.
Oh, okay. Cool.
She wears like a cloak
Yeah, go ahead.
with a little giraffe.
All right. Hey, does this work? Does everyone kind of understand this?
Yes.
Would this be something that was important? Like, if you were heating something up and you truly wanted to get this to be gold, you'd probably have a thermometer of some sort in your solution, wouldn't you think? I don't know. I'm just trying to convey how this lab would take place. I mean, I've certainly done this, and everyone thinks that they work for the United States Treasury, saying this is illegal. Is it? Yeah, I'm sure it is. Is the federal government worried about some pennies coming in that look like they're gold plated? I don't think so. If our
They're trying to take away pennies. What color are pennies? Pink.
they're usually copper,
Well, they were made silver back in the 1930s.
zinc. They're zinc. In 1940
Copper for bullets.
bullets. Yeah,
Yeah.
yeah, that's exactly right.
Oh, it was zinc? They
Yeah.
said silver.
Now they look silver.
On the
Silver
History
would be
Channel.
expensive.
Oh, really?
Yeah. So I guess history's wrong.
I mean, a lot of coins were silver. Like the quarter used to be silver. Now the quarter has a lot more copper.
Oh
in
yeah,
it.
those have been the
So yeah, but a penny they had in the 40s, I think it was, during World War II. They made them zinc because there was a copper shortage. And here's your Arizona history. I know you didn't pay for it, but you're getting it anyhow. There was a copper mine in Arizona that actually went on strike during the war, and that's what led to you've ever been to Florence, Arizona, or not Florence, Globe, Arizona, they have the biggest strip mine I've ever seen. And if you don't know what a strip mine is, it's you're driving along the road, and I mean you have a canyon, and it's just it's like it looks like a corkscrew going all the way down, and they're just digging out stuff, and then these trucks are driving back up it and dumping it, and then drive back down.
Oh, I would be too scared to do that.
But it's kind of a big gig.
I want to be a gold miner.
Gold mine. Elko, Nevada has the largest gold mine right now in the United States. So
Yeah, but they're gonna run this.
they could. You never know. But as for the past couple of years, it's been the largest gold mine in the United States. All right. And versus or. Okay. I can't convey this anymore. So. All right. What do you think TT stands for? True, true. TF, true, false, false, true, true, true. So, or problems, a lot of times will look like things being shaded away from each other. So, if you pick a point over here, or you pick a point over here, that is where the or problems take place. The and problems are the ones that come together, where you're shading just in between two things. Okay? Now, is it possible that the and keeps going forever both ways? Yes, that's infinite solutions. Is it possible or overlap each other and keep going both ways? Absolutely, and that could be infinite solutions as well. Can we move on? 1 second. So sometimes the or problem could look like this. See how they overlap? The arrows would keep pointing. So this could happen sometimes. Life good?
What does that say?
It's like that's the event.
Yeah.
Oh.
Event. E-V-E-N-T. Still doesn't look like event. I'm sorry. I'm not certified to teach English, just science and math. All right, moving on. Yay! Ooh, cool, deck of cards. What if I tell you the card I want is red and a king? Okay, how many red kings are in there?
2.
There's 2. You have 2 of them. Okay, does that make sense? And your red cards, you have diamonds and you have diamonds and hearts. Those are your red ones. Okay, yes, I understand there are some deck of cards that are 5 suit, but your traditional deck of cards is 4 suit, where you count ace as a 1, king is the high. Yes, an ace is a good card to have, but it's 1 through king in that order. What is the card I want? What is the card I want is red and a club. What color are the clubs?
Red.
Yeah, so this is a spade. This is a club. So the club kind of looks like this. Looks like a clover kind of. Boy, I stink at drawing. That's more rounded. And then the spade looks like this. Looks like a. I can't draw. Boy, who am I faking?
It sort of looks like a person.
It looks like a condom.
So spade looks like that. Club looks like it has 3 fingers. These are both the black ones. And then the hearts are red. And diamond is right there. That's the diamond. So, what card is red and a club?
No card.
None. Good. Does that make sense? So they don't overlap each other. What if the card I want is red or a king. So red cards happen to be, how many red cards do you think are in a deck? There's 52 in a deck. 26. So I have 26 red or a king. How many kings are in a deck? There's 4 total. Now, are some of those 4 kings red? So how many cards are we talking about in this situation? 26 happen to be red or kings. How many kings are there?
4.
How many of those kings happen to be red? 2.
30.
It's not 30. You can't count a card twice.
26 plus 4.
Is 30. You're absolutely right. But 2 of those cards, 2 of those kings happen to be red. So don't count it twice. Yeah, so you have 28 cards in there. Does that make sense how I just did that? So you have 28 out of your 52 cards that are either red or a king. Okay? And you don't want to count a red king twice. So you either count it as part of your 26 or you count it as part of your kings. You don't count it as both. What if the card I want is red or a heart? How many are red? How many are heart? How many hearts are red? Is hearts a red card? There's 13 of them. Okay, what if the card I want is red or a heart? There's just 26 outcomes in there, right? Because of those 26 red cards, those 13 hearts exist. The other 13 red are diamonds. Okay? What if the card I want is red or black? Well, that's one of the 52 cards. You either have the red card or the black card. Either red or black. So, before you all ask, I will answer this question. Do I know how to count cards? Yes. Is it illegal to count cards? Does anyone know?
Yes.
It is not.
Oh, it isn't.
It isn't.
Cards.
So what makes counting cards? So in the state of Nevada, if you are counting cards and you never alter your bet when you have the advantage, they could care less. Heck, if you're sitting there betting $5 on a hand and then you're counting cards and you go to $10, they're not going to bug you. It's when you're betting $5 and all of a sudden you put $2,500 on the table because you are now at a 61% advantage. That's where they're like, oh, I notice you're counting cards. Oh, yes, I am. I notice you changed your bet. Oh, yes, I am. Okay, this is the last bet. After this, you need to leave. Oh, I'm not leaving. Yes, you are. And if you return to the casino or any other casino, you'll be arrested for trespassing. And trespassing in the state of Nevada is a felony. Think of that.
You're a felon?
I am not, no. Not this week, maybe last week. Yeah.
Wait, so what's counting cards?
Okay. So you have a deck of cards. You with me still?
Yes.
Okay, in the game of blackjack, you're trying to get you're dealt 2 cards originally, as well as the dealer. Now the dealer usually has 1 card that you can see and the other card's down. You're able to see both of your cards. So you look at your cards, you're trying your cards to get to 21 without going over. Okay, so an ace is counted is worth 1 point or 11 points, depending on what you want to use it for. Face cards are 10, and all other cards are worth their face value. So 2, 3, 4, 5, 6, 7, 8, 9, 10 are worth those points. So when you count cards, what you're doing is you're actually only giving certain cards a +1 rating and some other cards a -1 rating. So you're just going up 1, down 1, up 1, down 1, up 1, down 1. And on a single deck, it's really easy to do because usually they will do 2 deals on a single deck. So you can kind of sit there and look at the table going, okay, I just saw 3 aces come out on that hand. So the next hand, I'm not going to bet as much because 3 of those aces of the 4 aces already came out. But a lot of times in Nevada, they will have 5 or more decks of cards that they're using, and they have these machines. They automatically shuffle them, and then they put them in the booth. And so when you count cards that way, by going +1, -1s, if you, at the end of your bet, if you're up to a +16, that means you have a higher probability of having face cards in the deck that still come out. Okay? And the later in the boot as you get, so as you've gone through a whole bunch of hands, because the reason they have 5 hands there is, 1, they wanted to make it hard to count cards. 2, they didn't want the dealer to continuously shuffle. They found that if I have a 5-deck boot, and there's 5 decks over here that are being shuffled in the machine while I'm dealing out of this, I can actually have more games because the probability of you beating the house in Nevada is very low. They don't build those casinos because people are winning all kinds of money. There's always somebody who in Vegas who will tell you, I have a system. No, you don't. Because the payout table on gambling. So what a counting cards really is you are going +1 and -1 because you're able to see everyone's cards playing blackjack, including the dealers. So you're counting to see if you can get it. If your end count you're at +16, it's in your best interest to increase your bet on the following hand because you have a higher probability of winning. That's really what it is. Okay? All right. Give each graph as an inequality and give the interval notation. So where is this going to? Where's this going to? Negative infinity. Where does it stop?
-2.
Do I include -2? No. Where does this start back up?
3.
Where does it end?
Infinity.
Infinity. All right, so I'm going to read this from left to right. Negative infinity to -2, rounded. It's an OR graph because it's shading away. Got it? And then it goes from rounded bracket 3 to infinity. And that's how we read, that's how we put this graph in interval notation. What kind of graph is this? It's an AND graph. It comes together. Where does it start? Goes to rounded brackets on each end because I don't include the endpoints. Okay? I don't need the word AND in here because they came together. On these, I need the word OR. What about this one? Same graph, but what about the endpoints? What do we know about these? They are square brackets because I include them. That's it. That's all it is. It's just a way of you grouping stuff together. How many more slides do I got? One more sheet or one more slide?
One more problem.
Oh, wow. Ready? Set. Go. All right. Use a graph to simplify the 2 inequalities and then give it an interval notation. All right. 2, 5. Are these open dots, closed dots, or one of each?
Open.
Good. And I shade in between. X is greater than 5, so it's over here. And then X is greater than 2. Okay. What do we know when it's an AND graph? I have to figure out where I can start plugging in numbers that will give me true on both of my equations. Okay? So, if I pick a 3, which is somewhere between 2 and 5, if I plug 3 in, is 3 greater than 5? No? Is 3 greater than 2?
Yeah.
So I have one true and one false, but when it's an AND, I need everything to be true. So I'm going to pick on the other side of 5. So maybe I pick 6. Is 6 greater than 5?
Yes.
Yep. Is 6 greater than 2?
Yes.
So this region over here is where everything is true in both of my equations. Okay? So as an interval notation, I'm going to start at 5 and go to infinity. And if I do that, I will find that everything I find in that region gives me true on each of my problems. Does that make sense? Good? All right, let's try this one. Let's do this underneath. Okay, so I have -2, and I have 4. Okay, 0 is like here. All right. I have a round bracket. This is going this way. And then I have a round bracket, and this is going this way. What did I tell you about OR? Do you have to have both of them true? No. Okay, so let's pick, say, 10. 10's over here, right? 10 is less than 4. Nope. 10 is less than -2. Nope. Well, nothing over here is going to work. 4 doesn't work because I'm not going to include it. But what's the number of 1 less than 4? 3. Is 3 less than 4?
Yes.
Works. True. Is 3 less than -2? No. But starting here and continuing that way forever, I will find at least one true for my problem. So on this problem, I'm starting here, and I'm going to go forever this way. So that's going to -infinity. So my interval notation is -infinity to 4. And anywhere in there, I will find either true, true, or true, false. Okay? And that's what the OR is taking place. The AND, they both have to be true. The OR, you only have to have one part. All right, let's see. 6 and 12. Open dot going this way. Solid dot going this way. It's an AND problem. So you're going between those 2 points. So I'm going from 6 to 12 square bracket. Done. Everything in between 6 and 12, and including 12, but not including 6, so 6.1 is the next thing, or 6.0, whatever. That would give us true and true on both. And then on this one, let's think about what this number line looks like. I got 2, solid dot, going this way. 7, going this way. It's an OR problem. Ooh. So this is going to continue to go this way forever. Agree? This here at 7, but it keeps going this way forever. So no matter what I pick anywhere on that number line, I'm going to get at least one true answer. Can I have at least one answer true on an OR problem? So what's my solution here? It's going to work forever left and forever right. So what's my solution? It goes from -infinity to +infinity. Everything in between works. So that's all real solutions. Okay? And then this one. So that starts at 0. -4, so I go from here, this goes this way, this is open, goes this way. Oh, wait, time out. I made my graph backwards, I'm so sorry. -4 is down here, 0 is here, so I have open dot going this way, I have an open dot going this way. Will they overlap? So if I pick anything down here, I would get true, false. If I pick anything in between, I get false, false. Over here is false, true. So this is a no solution. No solution. Your assignment for next time is just page 41, 42. Sound good?
Yes.
All right, it's a minute till. Get your phones. Get out of here. Have a great day. Take care of one another. If you needed